The Kuiper Belt, a distant, enigmatic frontier at the edge of our solar system, beyond the orbit of Neptune. Here lies a vast region filled with icy bodies, dwarf planets, and remnants from the early days of our solar system. For centuries, this remote expanse remained hidden, a mystery locked far from our view. But thanks to advances in technology, particularly the power of modern telescopes, we now have the means to peer into the darkness and uncover what lies beyond. Today, we embark on an extraordinary journey to explore the Kuiper Belt in a way never before possible. With the eyes of powerful telescopes, we'll peer into this frozen region and begin to unravel its many secrets. What can this distant zone teach us about the birth of the solar system? Could it hold answers to questions about the origins of comets, planets, and even life itself? The Kuiper Belt beckons, and we are only just beginning to explore it. The Kuiper Belt lies in the outer reaches of our solar system, stretching from 30 astronomical units (AU) to about $50 from the Sun. An astronomical unit is the average distance from Earth to the Sun, roughly 150 million kilometers. So, the Kuiper Belt is a vast, icy region, nearly 7.5 billion kilometers away, and it holds the remnants of the solar system's formation, objects that have remained unchanged since the early days of our cosmic neighborhood. But this isn't just a barren, empty space. The Kuiper Belt is teeming with activity. It's populated by icy bodies, dwarf planets, and an untold number of smaller objects, fragments of an ancient past. This region could hold clues to how the planets formed, how comets came to be, and perhaps even how the building blocks of life were seated on Earth. For decades, the Hubble Space Telescope has been our most faithful eye in the sky. Orbiting above Earth's atmosphere, Hubble has allowed us to peer deeper into space than ever before, and it has provided some of the clearest images of the Kuiper Belt. In fact, Hubble was instrumental in revealing the first detailed images of Pluto, as well as many of the smaller objects that orbit out there in the belt. Hubble has helped us track the movement of these icy worlds, uncovering the surprising diversity of objects that populate this far-flung region. We now know that the Kuiper Belt is not a uniform field of debris, but a complex and fascinating region filled with everything from the small, icy remnants of comets to the large, dwarf planets like Pluto and Eris. But it wasn't until 2006, when NASA launched the New Horizons spacecraft, that we gained our first detailed look at the Kuiper Belt. After a historic flyby of Pluto in 2015, New Horizons began to reveal the true scale and complexity of the belt, sending back images and data that forever changed our understanding of this icy frontier. As New Horizons ventured further into the belt, its findings began to confirm that the Kuiper Belt is not merely a relic of the solar system's past, but an active region filled with new discoveries waiting to be made. New Horizons is still sending data back to Earth, and it continues to explore regions of the Kuiper Belt never before seen by human eyes. It's a reminder that even in the farthest reaches of space, there are discoveries waiting to be made, and each piece of data opens new doors to understanding our cosmic neighborhood. While space-based telescopes like Hubble and spacecraft like New Horizons have offered us incredible insights, the exploration of the Kuiper Belt wouldn't be possible without the work of ground-based observatories. Powerful telescopes like the Keck Observatory on the volcanic peaks of Hawaii are helping us scan the belt for new objects, some of which are so faint and far away that they were previously invisible to earlier generations of astronomers. With cutting-edge technology, astronomers are able to capture images of Kuiper Belt objects with astonishing precision. The powerful telescopes use adaptive optics to correct for atmospheric distortion, allowing them to detect even the faintest light from objects that are billions of kilometers away. These instruments help us find new icy worlds, measure their sizes, and understand their orbits, pieces of a cosmic puzzle that is slowly coming into focus. Through these advanced telescopes, we are unveiling a startling variety of objects within the Kuiper belt. Some are large, like Pluto and Eris, while others are much smaller, rocky bodies, frozen remnants from the solar system's early history. But even the smaller objects hold significant value. They offer a unique glimpse into the past, revealing the raw materials that were once used to build planets, moons, and possibly even life itself. Each new object we discover brings us closer to understanding the complex history of our solar system, showing us how the planets and their moons came to be, and perhaps offering clues about how life emerged on Earth. Many of the comets that we observe today likely originate in the Kuiper belt. When a comet's orbit is disturbed, often by the gravitational influence of Neptune, it can be sent inward toward the Sun, where it becomes a brilliant streak of light in our night sky. The Kuiper belt, then, is not only a repository of icy remnants, but it's also a launching pad for some of the most spectacular phenomena in our sky. These comets have been traveling through space for billions of years, holding within them frozen remnants of the early solar system. As they journey through space, they act as messengers from the past, offering a glimpse into the conditions that existed when the solar system was forming, when Earth itself was just a collection of gas and dust, waiting to take shape. Every night, astronomers all over the world are engaged in this cosmic treasure hunt, peering through their telescopes, scanning the sky for new objects. With every discovery, they not only expand our knowledge of the solar system, but they also get one step closer to answering some of the biggest questions in science. How did the solar system form? What happened in the early days of the Sun and the planets? And how did comets, asteroids, and icy objects come to play such a crucial role in shaping our world? With each breakthrough, they not only uncover the secrets of the Kuiper belt, but also uncover more about the universe itself, about our place in it, and about the conditions that might make life possible on distant worlds. As we delve deeper into the mysteries of the Kuiper belt, we realize how vast and uncharted this region truly is. The objects here are far from static. Some are in orbits that stretch across the entire solar system, taking them on journeys that span centuries. Others are in constant motion, affected by the gravitational pull of Neptune and other distant giants. This dynamic environment holds endless possibilities for discovery, and every new object we find adds another layer to our understanding of the solar system's past, present, and future. The Kuiper belt, with its icy bodies and ancient relics, is not just a boundary between our solar system and the unknown. It is a key to understanding the origins of life itself. What we learn here could help us understand how the building blocks of life were distributed across the early solar system, perhaps even to distant exoplanets where conditions might be right for life to emerge. The Kuiper belt, for all its mystery, represents one of the final frontiers of our solar system. It's a place where we can look back in time, exploring the frozen remnants of our solar system's formation. And while our telescopes have opened a window into this distant world, we know that the full story of the Kuiper belt is still unfolding. With each discovery, we come closer to understanding the farthest reaches of our cosmic neighborhood, and perhaps, one day, we will learn even more about our place in the grand cosmos. Through the power of our telescopes, the Kuiper belt is no longer a distant mystery. It is a world waiting to be understood. And the more we explore, the more we find, not just about the solar system, but about the universe and the story of life itself.